Hello and welcome to episode 60 of the Our Weekly Highlights podcast. It's quite an amazing number to achieve, but I am thrilled to be here to give you another great roundup of the excellent highlighted stories in our latest issue of Our Weekly. And this issue in particular is issue 2021-40, which was released on October 7th, 2021. And this week's issue was curated by Jonathan Carroll, with help from the Our Weekly team members and contributors. Variety is the spice of life, as English poet William Cowper opined in 1758. I have a hunch that William did not consider practical applications of data science tooling in those days, but who knows? We have many choices available to not just accomplish our analysis task at hand, but also to blend different parts of the analytical pipeline together. We've seen in many of the previous highlights a lot of interesting facilitators of these analyses within the R ecosystem, and in particular the R Markdown package that on the surface is great for reproducible analysis and reproducible reporting. But it is so much more, especially when you can tie it to other packages in this ecosystem that generate your own sophisticated software pipeline. That is very similar to what Daniel Anderson, research assistant professor in behavioral science and teaching at the University of Oregon, has done with a very interesting project regarding student assessments in Oregon schools. One of the key innovations in R Markdown was introduced in version 0.6 with support for what are called parameters in the YAML specification within the header of an R Markdown file. What are parameters, you may ask? Well, you can think of it as a collection of objects that you can pass at compile time when your report is rendered in R Markdown's rendering function. These are typically static values such as text, maybe numbers, or perhaps even more complex objects. You can specify these into YAML directly to give you a set of defaults, which were translated into the rendering R Markdown function. But the key point here is that I said they were defaults. They can definitely be changed at runtime. Daniel has leveraged the params feature combined with additional tooling in the R Markdown ecosystem to create a highly stylized individual student report with template styling that we'll probably hear about in a future blog post on his blog. But the key point is that this is rendered dynamically with customized parameters at runtime. And certainly at this point, one could have repeated calls to the rendering function to produce different student reports based on simple manual invocations of the render function. But Daniel saw a bigger picture at play here and wondered if there was a way to put this as part of a pseudo production pipeline. Well, the good news is, within the R Markdown ecosystem and the R ecosystem in general, the possibilities are almost endless. And to make it as easy as possible to invoke these rendering functions, Daniel took the step of actually creating an API with the Plumber package to, in essence, wrap the call to the render function with parameters supplied as part of the API web address specification. In this case, getting started with Plumber was quite straightforward once you get the hang of styling the different header comments with the pound and asterisk signs instead of the typical R Oxygen layout to give Plumber the information it needs for what the parameters will be. And then the other key portion that Daniel customized is the return object of this API. Under normal circumstances, in a situation where you fold R Markdown into something like Plumber, the return object might be a downloadable HTML file with the contents of the template. But that's not quite what they had in mind. What Daniel wanted was a way to see the report contents after calling the API directly within the web browser of choice. With that, it was a simple tweak at the end of the rendering Pumler function to include a call to read.bin to, in essence, grab the temporary file that was created for the rendering function. And at that point, even with testing the API and Plumber's built-in Swagger interface, one can clearly see, as he's documented in the post, that the actual report itself is shown in all of its stylized glory within the web browser. With this, the possibilities have now opened extensively to be able to put this in to a sophisticated container created with Docker so that this reproducible environment can be installed on multiple operating systems or even as part of a bigger picture, maybe with cloud servers. Daniel mentions that those details will be coming in a future blog post, but this is something that really resonates with me, as a lot of times R is certainly one of the primary tools of my job, but we are definitely looking at ways of integrating R in very sophisticated analytical pipelines. And in this case, you can start really quickly just looking at the extensions from the community to build your own reproducible analysis workflow with R Markdown, Plumber, and anything else from your imagination. And speaking of pipes or pipelines, our next story takes a very extensive look at the history of one of the bigger revolutions in the R ecosystem of the past 10 years. It's no secret that in 2021, we have had a major update to R itself, in other words, the base installation of R, with the introduction of the native pipe operator. But how did we get here? It is an interesting tale of open source collaboration, what seemed like innocent questions on certain forums, and serious momentum after community adoption. Adolfo Alvarez, senior data scientist at OI Glass, has put in one of the most comprehensive looks at the history of the pipe operator in R on his latest blog post, the subject of our second highlight today. It has been well documented that R itself has been heavily inspired by other languages, certainly in particular the S language, amongst others, for some of its native solutions. But a lot of other languages can have different ideas for various plumbing, so to speak, such as a language called F#, which showcased a forward pipe operator. And so on Stack Overflow in January of 2012, an anonymous user asked about if there was a way to implement this intriguing pipe operator in native R itself. Well, that post certainly found its share of answers, and little did we know what that would lead to. And in particular, later on that year, we saw the introduction of the ptools package by Peter Melstrup, which was later renamed to the Vader package. I admit that's one of the cooler names I've seen in package names, which introduced its own take on this operator with the chain function. Later on in that year, Hadley Wickham released dplyr, at least a development version, on GitHub as his massive rewrite of the existing plyr package for data manipulation. At this point, these two paths have definitely not been crossing yet in terms of where dplyr was going and these native packages for a forward pipe operator. Hadley took it upon himself to actually implement his own version of what became a chain function in a later update of dplyr in 2013. The motivation was to give users a way to avoid a whole bunch of nested function calls when they wanted to do different operations in sequence on an input such as a data frame. And as Hadley was ironing out this feature, again, in an independent development, late in 2013, Stefan Bach had authored the Magrider package, which actually came from an answer on that very same Stack Overflow post asking about the F# operator within R. At this point, there are in essence three different development paths going on that have some form of a pipe operator involved. The convergence started to happen in 2014 when Hadley released dplyr initially on CRAN. And on the very blog post that announced this on RStudio's blog, Stefan actually led a comment on that blog post, making sure he reminded Hadley of his existing Magrider package and his take on the pipe operator. Well, the collaboration began shortly thereafter, and in fact, later on in the story, in 2014, Hadley deprecated his version of the chain function and instead imported the Magrider function and its version of the pipe operator, and you could say the rest is history in terms of the tidyverse itself. It is important to note that Magrider is not the only package in town for piping operation. We heard about the Vader package beforehand, but another interesting package came around in 2014 authored by Kuhn Ren called the Piper package, which introduced a little more flexibility and certain additional features to the piping process, and it has certainly received good feedback across the R community. In addition, in 2018, John Mount and Nina Zumel authored the Wrapper package, which again had a little bit of a difference between the Magrider pipe and even the Piper package, giving now 3, and you might say 4, different alternatives to the piping operation within R. And no matter which framework you may be personally using, it is undeniable the fact that the pipe operator has had a transformative effect on how many in the data science community are leveraging R for data analysis. And thus far, these efforts have been external to the R project itself in terms of the base installation. But RStudio software engineer Leon O'Henry began a dialogue with the R core team in 2016 with a proposal about introducing a native pipe operator starting with R version 4. And unlike the rapid iteration we saw in the early history that we talked about just now, there wasn't a lot going on after that initial proposal, at least seen from the public eye. We obviously don't have privy details on how the R core team themselves had talked about this, but the momentum started to shift in favor, so to speak, in 2020 when Luke Tierney, in his keynote at the UseR conference for 2020, had a very specific slide dedicated to the proposed native pipe operator that would be in base R, along with some high-level features that they were considering and differences between the Magrider pipe in order to enhance performance and to bring a little more standardization to their version. The momentum carried on, and sure enough, at the end of 2020, the native pipe operator was introduced in the development version of R. Certainly, there was a lot of reaction that was sparked in the community. Certainly, some were not as thrilled with the initial implementation of it, and others were ecstatic to see this. But that's just like anything in open source. You can't please everybody, but it was certainly a huge advancement in terms of where the base R installation was going to adopt a very important paradigm, especially for those learning R for the first time. Magrider itself did not stagnate, and in fact, we covered in a previous R Weekly Highlights episode how Magrider version 2 has become a complete backend rewrite to shore up performance hits and to make sure that it could be compliant with R version 4 and beyond. Now, throughout this explanation, you saw hints of paths in open source where multiple developments are happening, sometimes completely isolated from each other, at least in appearance. But with continued collaboration and reaching out to various maintainers, there always exists a possibility to unify approaches and perhaps even change the direction of a larger project. While the road to the native pipe operator hasn't always been smooth, again, we can't deny the importance of this in terms of the history of R itself and how R is being used in data science. I certainly enjoyed reading Adolfo's post, and I would hope more come in a similar vein for some of the other advancements in the R ecosystem, because having the history and the context of how these important features are came to be is just my kind of history lesson. And rounding out our highlights today, we have an interesting take on the interplay between R and different languages to accomplish tasks that, frankly, myself a few years ago would not have thought possible. A key component of exploratory data analysis is the ability to uncover insights from perhaps specific research questions, or with an open mind and a clean slate to figure out what this data is really meaning in a bigger context. One of the most powerful techniques in exploratory data analysis is visualization of the data you have. Sometimes we don't always go to that right away, especially if we have been asked to look at a very specific component that may only need part of the data or summarize data in different ways. It has been shown in years past in projects such as the Datasaurus dozen that one can make very different looking distributions of data that yet have similar summary statistic properties, perhaps a similar mean or a similar standard deviation. Well, there was a recent research paper by professors iamYannC and Martin Lurch where they tested a hypothesis of an experiment where students were given either not much background knowledge for an analysis of a data set or a specific question, or you might say a specific hypothesis to address. And the funny part was that the data that they were given was actually taken from an image of a friendly looking gorilla saying hi to you. They were able to leverage a Python package or a set of Python scripts to actually extract the position of pixels and their different colors from that image and translate that into coordinates that could be put on a two-dimensional visualization. Well, that's certainly a fascinating concept, and apparently I'm not the only one that thinks that's fascinating. Isabel Velasquez, who now works at our studio on the marketing team, thought this was a great opportunity after seeing the attention that this research paper was getting on social media to try doing this within the confines of R, but taking advantage of the integrations that are possible with Python to bring this in a single interface. And in fact, what is that interface that's driving all this? Well, it's what we talked about in the first highlight. It's R Markdown. So in Isabella's blog post, she starts with a very detailed overview of the packages that you need to recreate this. And obviously one of those is Reticulate itself. And there are going to be some considerations for you to make sure that Python is available on your system. And in particular, the pillow package within Python is the image library that's going to make all this magic happen. But again, we are going to see some of the main advantages of something like R Markdown, where Isabella can easily interweave Python chunks that are importing the modules and performing the image extraction of these pixel coordinates, and being able to save that into an object that can be brought back into R. Now, how does that happen? How do you actually bring something that was created in Python into an R session within this same umbrella of R Markdown? There is a nice object that's created in these R Markdown Python chunks called Py, which is able to be referenced from an R chunk as what can amount to as kind of like a list object where you can get different slots of the objects you created in the Python space. Well, in this case, those set of coordinates was simply a matrix. So once Isabel was able to grab that from the Python session, she was able to leverage a little bit of dplyr munging and be able to put that into ggplot2 to create the friendly looking gorilla in all of its ggplot2 glory with some additional bells and whistles such as different colors. It's excellent that we can have interoperability in such an easy fashion within the R ecosystem, and in particular, R Markdown. And those are your R Weekly highlights for today. Jonathan, as always, has assembled an excellent issue for us to take a look at and geek out about all things R, and some of the additional stories that certainly caught my attention was a great post on how to use the Shiny Matrix package combined with Plotly as inputs into a Shiny app with a very relatable example in manufacturing. In addition, there is also a great roundup of the top 40 new R packages on CRAN, an interesting package called Gozer to add destruction artifacts to R objects, a video tutorial on documenting functions in your packages, and much more. And without revealing too much, I can tell you that there are potentially some big things happening for the future of this podcast that perhaps, if things go well, next week I will be able to review a big surprise that I think is going to change the direction of the show for the better and certainly make this show grow hopefully even more. And speaking of growing, I just want to thank all of you out there for listening, as the number of downloads for the entire life of this podcast has now exceeded 10,000 downloads across the world. That to me almost seems like it doesn't even make sense, but I am so thrilled that the content that we are sharing here as part of the broader R Weekly initiative is resonating, and we certainly hope that you enjoyed this and future episodes of this podcast. Well, where's the best place to go for R Weekly? Well, that's simple. You go to rweekly.org and you'll see the current issue in its entirety, along with all the archives of the previous issues in case you want to refer back to some of the stories we mentioned in the previous episodes. And there is a direct link at the top of the page where you can get to the specific show notes for each episode that we released on this Highlights podcast. And certainly don't hesitate to get in touch if you want to share your feedback. You can reach out to me on Twitter. My handle is @thercast. And you can also contact the R Weekly team themselves by visiting the feedback page and the R Weekly site. Have a fantastic week, and we'll be back with another batch of R Weekly highlights next week.